Alright, so today we have an interesting problem. So let's see, we have log base 2 of 3 times log base 3 of 4 times log base 4 of 5 times blah 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 continuing the pattern, and it ends with times log base n of n plus 1, and all that's equal to 10. Alright, so I'm looking at the problem, and I don't see much I can do, because, I mean, look, we're multiplying logs, right? So I don't think there's much of a property for that. But what's even worse is that all the logs are of different bases, like log base 2, log base 3, log base 4, log base n, right? So that kind of makes it a little worse. So what I think I want to do is maybe simplify this a little bit. Maybe at least bring all the logs to like a common base. Maybe put a change of base on all of them and convert them all to, like, I don't know, natural logs. Convert them to logs of any other base really, but I'm gonna choose natural logs just to be, I don't know, like, I don't know, I just like natural logs better. So I think I'll do that. I'll do change of base on all of these. So first term will become natural log of 3 over natural log of 2 times second term becomes ln 4 over ln 3, then third term ln 5 over ln 4, and then so on, right? And then eventually our last term becomes ln n plus 1 over ln n, right? And all that is going to still be equal to 10, right? We didn't do anything to the right hand side, just to change the base and everything, right? Alright, so at least all the logs are in a common base. Maybe that'll help, right? Okay, alright, I noticed something interesting. I see that the numerator of the first term and the denominator of the second term, right, they cancel, right? And the numerator of the second term cancel the denominator of the third term, right? And I think that's gonna happen, and that's gonna continue on until ln n plus 1, like until the last term, right? Because it's gonna be because if the thing continues, we're gonna have log base 4 of 5, then log base 5 of 6, right? So we'll have ln 6 over ln 5, and ln 5 is here, and the ln 5 up here will cancel out, and then yeah, it'll be more cancellation. But what I noticed so far is that the numerator of the first term, right, gets cancelled by the term after it, right? And the denominator, let's see here. So let's see here. Numerator of the first term gets cancelled by the fraction after it, and the denominator of a term gets cancelled by the numerator before it. Alright? So like if that doesn't make any sense, like ln 3 got cancelled by the ln 3 down here, but ln 4 down here got cancelled by the ln 4 up here. So it may seem confusing, but what I'm trying to get at, for the last term right here, because there's going to be a bunch of cancellations going on, right? So for the last term, ln of n plus 1 divided by ln of n, right? Since there's no term after it, right? I think I don't think, the numerator is going to stay, and the denominator will get cancelled by the numerator of the term before it, right? Because actually, I could explain this a much better way. I mean, I could just rewritten the term before it, right? So the term before would have been ln of n over ln of n minus 1, right? And times ln of n plus 1 over ln of n, right? And then you'd see that the numerator here and the denominator here would cancel, and the cancellation would have kept going on all the way up to here, right? I think that was a much better way of explaining it. So if you understood my first explanation, good job, because I don't think even I understood that. But yeah, overall, we'll be left with, because there'll be a bunch of cancellations going on, we'll end up with natural log of n plus 1 over ln 2, and that's going to be equal to 10. Alright, now let's see here. So I see, okay, alright, let's take a look at this. I have a fraction, natural log of n plus 1 over natural log of 2. That kind of looks like a change of base thingy, right? I think I could rewrite this as log base 2 of n plus 1 being equal to 10. I think I can do that, because if I do the change of base again, I just get, if I want to convert into log base, I just get ln plus 1 over ln 2, right? So that's fine. This is already change of base format. I just rewrote it as log base 2, right? I don't want to deal with e's anymore. I think I'm able to do this in my head now, because to solve this equation, I can just exponentiate both sides, right? Just like put him as an exponent of a power of 2, make him a power of 2, right? Then the 2 here, and this 2 base and this 2 of the log, right, they'd cancel. We get n plus 1 is equal to 2 to the 10th and then do subtraction of 1 by both sides, on both sides, we get n is equal to 2 to the 10th minus 1, right? So, and then we just do the math, right? Because 2 to the 10th we can do, that's just 1024. So you get n is equal to 1024 minus 1 is equal to 1023. And that's our answer. So pretty cool problem. If you use a change of base, yeah, so change of base is basically really how you solve this problem. And then you get a bunch of cancellations, and then you can unchange the base, I guess, if you want to call it like that. So yeah, not too bad, and stay tuned for more cool stuff.